We're going to move straight into looking at whether CBM has been winning over the critics. So, we're going for a number of years now, and Conrad mentioned in his initial talk, we have these same kind of arguments that come up time and time and again. And the big question is, have these changed? Are we actually making any progress with these people who think CBM is all wrong and is going to mess up maths education? So, since Conrad's done his various talks, TED, different conferences, Learning Without Frontiers, for example, looking at the number of views, we've had nearly 800,000 video views. So a lot of people are seeing the content of CBM, seeing the message of CBM. Obviously, we have the computer-based math website, people signing up to that. And you can see here, we've just done a little analysis of the different countries. So 130 countries are now signed up to CBM in some form or another. Interestingly, the vast majority in the United States, then the United Kingdom, and then smaller percentages for the other countries. I don't know quite how to read this graph. Maybe you could look at this and say, well, maybe the countries that are most represented have the biggest problems with their maths education. You can discuss that later. And certainly Conrad is getting a lot of coverage. So, he's being listed as, someone to really keep an eye on, one of these people, great thinkers, who's going to change the world with his ideas on maths education. So we're really making an impact in this sphere. But as I said, we still have these kind of standard arguments that come back time and time again. So you have to get the basics first. Computers dumb down maths, and hand calculating teaches understanding. So just having a little look at some of the YouTube comments, we've just, again, done analysis on that. And we see actually, the majority of the comments are pro-CBM. People understand this message and they can see the need for change. There's still quite a few people that are anti-CBM. Again, using these different arguments. Quite a few people sitting on the fence. They don't know. They don't know quite how this is going to play out. And of course, with YouTube, there's a load of completely irrelevant comments about what people in the audience look like. So I think the most interesting point, looking at these different arguments now and working through these, is actually the first argument. You have to get the basics first. It seems to have disappeared. I've not really seen many references to this at all. You notice John lurking here, our content director, to my side. I'm just going to ask him to kind of chip in every now and again to see what he thinks about what people are saying and how these arguments have changed. So I don't know if you have any thoughts, John, on why this idea that you have to get the basics first seems to have slowly disappeared from the argument.
Yeah, for me, I think one of the things that's difficult to pin down is that because a lot of people haven't got clear thinking about what their objections and the agreements are, then you get the very kind of emotional gut reaction. And so a lot of these ideas actually get mixed up together. And so the basics thing, I think, has morphed a lot into well, you've got to develop skill first before you let the computers at it. And it's become a case of time and place for a lot of people. I still think it's still fundamentally the same argument. They still believe this, you've got to be able to do it by hand and therefore have some basic understanding before you can accelerate with the computer. They just seem to have lost that terminology. I don't think the idea's gone away. Yeah,
I think I would agree with that. And certainly, as you see, looking at the arguments computers dumb down maths, we'll see elements of that in here. So here are just a few comments that we've picked out. So again, media, very keen to, say, Conrad Wolfram is stating this argument, and this is going to transform the world. So the media, happy enough to put this message out there. But when, again, we drill into some of the comments that we're seeing, a couple of comments here. First one, calculators actually do dumb down people, as all you're required to do is simply punch in the numbers and read the screen. It's more engaging when you're required to think and work out a problem step by step. Think, check their work. But I do agree, a lot of things we learn in math are pointless, like imaginary numbers, matrix, etc. Yes, interesting. And another comment below that. How much more watered down can you get than allowing our kids to use computers and calculators to do their thinking for them? Now, I think in both those comments, I think the interesting word here is think. So they both use this term, not required to think. I wonder whether there's just a fundamental confusion here, and John, maybe, again, you can comment on this, with thinking and calculating. Are people confusing these two ideas?
Yes, and actually I think the second one here is really telling, because when you showed me the talk you put together here, there's a theme that you'll see comes up again and again, which is people are interpreting this in terms of their understanding of maths. And so I think that really says so much, that second one, that the person thinks that we're stripping out all of the intellectual content, but then goes on to prove that they don't really know the scope and extent and excitement there is out there in maths. So this person is defining what we're doing in terms of the bits that are below that, which is basically arithmetic or simple algebra. And so in that sense, if that's all they think maths is, then we are destroying the subject. We are just taking out everything out. And because this person, and I think most of these comments, have really never done any of the proper thinking in maths, they don't know there's more to the subject than computation. And this, I think, is the central argument we need to push again and again, is that what we're putting into the subject rather than what we're taking out. And that's been, to some extent, a mistake of highlighting things that we can do that automatically that are no longer important, rather than emphasizing what we aren't doing that is so important.
Absolutely. And I think the next comment is, puts it very clearly. A calculator computer is only as clever as the person using it. And I think that's really the point. And below that, again, we have a comment here from Eric Schmidt. So this wasn't directly commenting on a CBM site or anything like this, but this was just a comment he made in general about education in computers and mathematics. So the way to work this out is for computers to do the things that they're good at, like knowing and remembering everything with great accuracy, and for us humans to do the things that we're good at: emotion, fun, intuition, creativity, reproduction, raising a family. So I don't know quite much how much we paid him to say that, but that's really, really on topic with the message of CBM. And again, I think it shows, we're getting quite high-profile mainstream figures getting that message and repeating that message. I don't know whether he's actually, read any of the things that we've been putting out there, but certainly this message that computers are dumbing down maths and education, people aren't really getting that anymore, and people want to see computers used for the things that computers are good at, and people doing the things that they're good at.
Interestingly, when you think about it, it's slightly more verbose, but it's very much the same kind of quote as the 20-year-old Steve Jobs quote that Conrad brought out yesterday about concentrating on the prose of math rather than the grammar. So I think some ideas that we could probably lift and reuse ourselves.
Definitely. Let me just move on. So moving on to one of the other opposition we see. So hand calculating procedures teach understanding. So again, this is very much kind of in trend at the moment. So things like long division. So again, we're getting some media attention. Conrad Wolfram saying, and he's mentioned it earlier yesterday, he can't do long division, but he doesn't see a problem with that. Why are we teaching long division? It's a skill that is not needed. And again, you don't have to go far looking into comments to see various people saying, so 50 years after learning about solving quadratic equations, I still haven't found a use for them. So learning procedures, they're not necessarily understanding what they're doing and how it actually applies in other ways. And the next comment here, I feel the same about mechanical rote procedures, but teaching children to set their maths out well and systematically is a useful skill. So this kind of changes the argument slightly that procedures aren't necessarily teaching understanding, but actually it's a useful skill to do in terms of setting out and systematic working. So I don't know whether that's something that maybe computer-based math has missed. What do you think, John?
Okay, there's sort of two levels to this one, I think. One is that a lot of people have this innate feeling that doing it by hand teaches you something more. And very often when you actually get them to articulate an example and go through what does long division mean to you or whatever the example is, they sort of have a moment where they go, well, actually, yes, I know it works intuitively because I've done it lots, but doing it lots didn't actually teach me why. But it's slightly more complex than that because there is definitely a layer at which doing it by hand does teach you stuff. The question is drawing the line, and that's I think, a challenge that every time we sit down and think about what some content should look like, the question is where to draw that line, that maybe with algebra, doing some very simple cases to get a feel for how symbols move around is useful. Developing that skill and being able to crank it up to be able to handle very large expressions that you might have at an A-level at the moment, that probably isn't a useful skill. So this isn't one certainly to completely brush aside, but very often it collapses when you really ask people to go into explain in detail and look at examples with them. They realize they don't believe it quite as much as they thought they did. But that sort of basic language of maths, I think, still needs a whole bunch of hand experience before you move up.
And of course, we still have people who are absolutely think that procedures teach understanding. So I won't read this next quote out, but you can read it for yourselves. A person who's extremely skeptical and really believe that hand calculating gives people an understanding that they can't get in any other way. And again, I said this is very topical at the moment. So there was a few months ago this issue of whether rote learning should be the vital part of the primary maths curriculum in schools here in the UK. And again, long division was the kind of the key point of that. Should children be doing long division? It was quite interesting to have a look into some of the rationale for this decision. So here's a quote from the now defunct schools minister, and this was the rationale for teaching these procedures. So, addressing academics and teachers, he quoted a study from Carnegie Mellon University in the United States that found primary school children with a good grasp of long division and fractions were more likely to go on to achieve high scores in algebra in their teens. Now, again, I think this next comment is quite clear. Actually looking at this, there's a bit of a problem here in terms of there's a correlation but not a causation. There seems to be an implied causation looking at this study, and that was the rationale, or maybe one of the rationales for putting long division as something that our children should be learning. I think this raises an interesting question again, whilst we're looking at the general idea of what we should be doing in maths education. Do the people who are shaping maths education in countries around the world, do they actually understand the statistics? Do they understand the maths themselves to be able to shape policy? I don't know if you have any thoughts on that, John. It's quite a difficult question.
Well, yes, this is an extension of the people who went to university earned more. So therefore, if we sent everyone to university, everyone will earn more kind of argument, isn't it? It's a central problem that at least in this country, governments are relatively conservative, not least because we've got a conservative government right now, but they tend to look at historical past. And one thing I think we have seen is the population has moved on this, I think, faster than government, at least in this country. In some other countries, we've seen the opposite, where we're having some conversations with progressive people, but here at least, this is sort of very typical, where it's people in the public who are pointing out what's wrong with what government's saying. And actually, generally, I think a trend that we've seen over the last year or so is that at the beginning, this comments and discussion was split between people who said, at last somebody's saying this, and other people saying, what a ridiculous idea. Now we see actual debate going on in lots of these discussions where people will say things, and more than in the past, somebody will come out with an actual decent argument against. So whether or not the masses winning over, I don't know, but the ideas are getting debated properly.
And we've got a nice comment here at the end of this section from Philippa Forrester, so a TV broadcaster who is involved in Tomorrow's World, just as Maggie Philbin was yesterday. And again, she's really saying here that in her experience, rote learning, only got her so far, and she wanted to know, how does this relate to the real world? And actually, this is, I guess it's not an argument, but one of the pros that we really say about computer-based maths is, we can have real-world examples and use real-world examples. And this is something, again, which is coming out very much in the comments. So actually, the top comment on YouTube for Conrad's original TED video is this one here. So I think one of the biggest problems is that half the math teachers out there don't really know that much math. Most don't know how to apply calculus to real life, so they resort to teaching how to calculate. Again, I think this is quite an interesting comment, and there's a string of replies underneath, and you can read those for yourself. But certainly, again, in the news recently, we see that the government is looking to introduce tougher tests for teachers, tougher English and maths tests. And I'm wondering whether this has hit upon a problem that actually procedures could actually be a way of hiding the fact that maybe you don't know the maths that well yourself, and you can just teach procedures. I don't know if you have any thoughts on that, John?
We face this constant problem, actually, that different issues get conflated. And in fact, CBM partly came out of frustration of every time there was some big government report coming out on maths, we'd get excited and say what they're going to say about it. And all the reports would talk about structural things, like if we set up this kind of management structure or we train teachers in this way, all the problems will be solved. And they never looked at the subject. So we're seeing the same thing there to some extent, where it's blaming the teachers for problems in maths, ignoring whether or not the subject's right. I mean, it may or may not be true, but I don't think it's something that is. We have to separate our issues out from those so they don't get all mixed up together.
And I think, as I said, moving on from the kind of standard arguments, we're seeing new arguments and new discussion points coming out from these comments. So again, another one of these comments is really looking at, what is maths and what are we teaching? So Roborexosaurus, fantastic name, says, Conrad Wolfram is forgetting about the world of pure mathematics and is focusing on applied mathematics. Surely he, out of all people, would understand that mathematics is for mathematics itself, and with the main motivation being applications. So I don't know whether we're seeing more and more of a split here about what we should be teaching in maths and pure mathematics and applied mathematics. And we heard from David's students yesterday studying maths for very different reasons. I wonder whether we're seeing more of a split at the moment.
Yeah, and this and other versions of it was something I wasn't really prepared for. A lot of the arguments stem, I think, from ideological fights over what is maths. And if your view of it is that the height of maths is to go down the very pure route and spend your time studying ideals and rings, then CBM seems very alien because it doesn't seem obviously lending itself to that. And then the people who haven't gone very far and think maths is arithmetic, well, they see this as just being calculators and therefore what's left. You could feel like you could solve it if you could define what maths is, but that's going to start a war, so I don't think I really want to go there. You see the same thing with things like Lockhart's Lament, which I'm sure many of you have read. I love the opening and what he describes as wrong with maths, but then goes on to describe how maths should all be about forgetting reality, and maths has nothing to do with the real world. Well, it maybe isn't constrained by the real world, but maths without the real world seems utterly pointless. It becomes navel-gazing if it's got nothing to do with the real world. And these are kind of, it's deep-seated ideology, I think.
So just one final point, I think, which has come up as a new discussion point as we've been working through these arguments, is the idea of numeracy. So I don't know if Mike Ellicock is here today, but Mike Ellicock from National Numeracy gave us a bunch of statistics about the problems with numeracy in various countries and how to tackle that. And this seems to be an issue, I won't read these particular quotes, but this seems to be an issue which is coming up again and again. So we have here Chris Jones from the City and Guilds, so they're the largest vocational course provider in the UK, saying that numeracy is a hidden problem which is blighting the UK economy. And here's a comment above that, just someone commenting on a maths piece, saying we're missing a massive problem here. Computer-based maths doesn't necessarily address numeracy. I think this is a really interesting point of discussion. Does computer-based maths address this issue of numeracy?
This has been an argument between me and Conrad for some time that I am, I think, coming around to his point of view on. At the beginning, I argued that computer-based math was really at the upper end. We were talking about A-levels, GCSE type, and we had relatively little to say at the lower end. The more that I talk to educators about concepts and sort of deep-seated concepts that are built upon the basics, the more I'm coming around to Conrad's view that if we did this properly, if we had the resources and the time and won over the arguments, that this would pervade all the way down to the beginning, everything pretty much above times tables and numbers. The way you think and the way you build ideas, there's almost no bottom to how low the influence is. I don't think I can talk for probably quite a while about that, but we're over time, so let's...
So what are we actually seeing? Well, I think one of the main points is we're at the centre of this discussion. So provoking new discussions, looking at the subject matter of maths all the time, and people are debating this issue. You don't have to go far to find people debating this all over the internet. Interestingly, the arguments have changed slightly. So, as I mentioned before, some of the arguments seem to have completely evaporated, which I think is a fantastic result. And some of the arguments which are persisting, you see people commenting on each other's comments, people correcting each other, which is great. But there are new issues that are coming out, new discussion points, new areas that I think we really need to consider as we're looking at computer-based maths. But interesting is, as John said as well, we're seeing great kind of prominent figures in industry making these great statements which are really in line with what we believe in terms of computer-based maths. But it seems that governments are still lagging behind. This move for change, it's just not quite happening yet for whatever reason. And there are still some confusions that remain. So looking into these different issues, CBM versus computer-assisted maths, for example, and this idea of rote learning, and how is that thinking? Is that giving people understanding? I think the point is, this is something which we continue to discuss, and this has been a very short session, but we want to keep this discussion going. We want to keep this movement, and certainly as this becomes, even more in the public eye, hopefully we'll also see government opinion catching up with the opinion of you and I.